Welcome everyone, and thank you very much for joining today, where we will be discussing large language models. My name is Xime Shachiri, and I'm part of the team at the Office for Financial Market Innovation and Digitalization, and I have the pleasure of moderating today's BIC session. We all know or have heard of ChatGPT, Mistral, DeepSeek, and Gemini, and all the others, other LLMs, and we will discuss today what's the difference between open source and closed source models, what these models actually can do and will do in the future. And for that, we have Mario Russi with us, who is Senior R&D Engineer at CSEM, and who will give us a deep dive into this LLM topic today. Mario, I would actually already like to hand over to you and your presentation.
Thank you very much for the introduction. So let me share the slides, and I give some seconds so that everyone has them properly displayed.
It's working for me.
So then let's start. So I'm sure that since the release of ChatGPT, most of you are thinking about how can I use AI in form of large language model for my professional or for the private life. And when these models came out, you saw in the news like big, bold statement, like the one from Jensen Huang, CEO of NVIDIA, that basically with AI, everyone can be a programmer or even more. With AI, everyone can do anything. And also Hollywood is talking to us a lot about how they think AI looks like in the case of movies. But actually, AI is more like this. It's heavily relying on statistics. And in the end, it's always the same. You have an input. These can be text, can be an image, video, some sensor, machine data. We have an algorithm. That's the AI in that sense. And you have an output that hopefully is what you wanted. But I don't want to blow this up now into an applied statistic lecture, but I rather talk with you about what's like the implication, the application of such AI models, and it should hand you as a navigator through the space, since it can be quite complicated. To start with, let's have a look how actually the difference is between an AI algorithm and the standard classical algorithm as we have previously known it. And let's have an example of the computer vision space here, because images is something that we humans understand very well. However, this applies for all the different modalities of input, no matter if it's now image or text, etc. So let's assume we want to have an algorithm that tells us now in an image if we have a chair and where the chair is. From a classical way, you could think of what actually does make a chair a chair. Well, typically it has 4 legs, you have a place to sit on it, and you would make some rules hard-coded to the algorithm to know what now a chair is. But we all know there are thousands of different variations of chairs. So they're not only chairs with 4 legs or 3 legs, there are chairs with rolls in different colors, in different sizes. So it becomes practically impossible to code here an algorithm that has all the rules for knowing what the chair is and what it is not. And here comes the whole magic of AI. You are no longer making an algorithm where explicitly a human defines what it should do now, but you have an algorithm structure, you have the data which contains chairs, and the algorithm itself figures out how it now can differentiate if it is now a chair or if it is not. And in media, you often see the very bold statements about human has around 100 million neurons in his head, in the brain. And then it is said that the latest LLMs from OpenAI have around 10 times more of these parameters inside. And then very quickly the question comes up, well, we have now a structure with this AI that mimics the human brain and has a lot more parameters actually. Does this mean now that AI is like more intelligent and more capable than a human? But actually it's not that easy, because it's not only about how big your algorithm is, it's also a lot about how is the connection made. Here, a French guy had a totally normal brain, normal life with like a mini brain. Nothing against French people here, but it shows us that it's not only about how powerful your algorithm or like the hardware you have is, it's a lot about how the connection is done. And not only connection is important, what is also highly important is the data with which you train, with which you adapt your algorithm to your problem. And often the dream is that you have a certain amount of data, or you collect new data, you throw that into an AI and gold turns out. Unfortunately, the reality looks a little bit different. It's as usual, if you have garbage in, you also have garbage out. That's why it is extremely important what data do we have. And it's not only important the data that we have, but also the data annotation. That means not the pure data itself, but connected, the know-how, the interest, what we have with the data together. And so it's also not that easy if you have now this data, you acquire this data, that you directly jump to the actual AI or data science. There are many steps in between it. Once you have your data, you actually need to have the processing pipelines for this data, because often the raw data itself, it's not cleaned, data is never perfect, and you have to transform it. Afterwards, the big question, how do you actually save your data? How do you clean your data? How do you validate that you actually have this data quality? And maybe at the beginning, it's a quite easy question to address. You say, yeah, I just store it now on a computer somewhere. But when you think then ahead in the future, in 1 year, 5 year, or 10 year, it's a lot of question, how does this data scale? Will you still have it in-house? Do you have it somewhere in a cloud? And often very, very important is a meaningful visualization of the data that you actually have. Because somehow you need to validate the data. Firstly, that it's really actually the data that you think it is, and that it has the quality and the information connected. And then on the very, very, very top, we have then the actual data science and the algorithms, which are just a part of it. And that's often not an easy topic. Williams, the Formula One company, recently got a new CEO, and he was completely surprised how much manual stuff they're doing there. They were still managing a lot of tasks simply based on Excel. It caused a huge confusion. So even companies who spend hundreds of millions each year in R&D are facing these difficulties with transforming to a modern, innovative company. And that's where CSEM comes in place. CSEM, as a private public company, has one mission. We transfer technology from research to industry. We have different locations in Switzerland, and we have over 600 people. And one hot topic, of course, is the whole digitalization. But now let's talk about what we are here, about large language models, or short LLMs. In the end, an LLM can be described quite easily. You have an input, which is some words, or like a prompt that you give. And what the LLM is then continuously doing, given on the words that it has as an input, it calculates probabilities. What is the next word? So if you have the sky is, what could follow next? Well, maybe it's blue or clear, usually or also some other words. And then it just takes the one with the highest likelihood, and that's then our output. Most of the people probably know LLMs since ChatGPT released their models at the end of 2022. However, the history goes much longer, and originally started already 20, 30 years ago, where you had algorithms, so-called recurrent neural networks, which processed serial inputs like words. And today's space, it's quite crowded. We have many different companies, and sometimes it gets a little bit confusing. So we have companies, and companies have models. And of these models, you have different versions. And latest with the versioning, it becomes quite crowded and complicated. Primarily, this is coming from because each of these companies is developing different models in parallel, and they actually don't even know which model that they're actually now developing will be released at which point and how much development it takes. Therefore, we see with OpenAI, for instance, you had GPT 3.5, then 3.5 Turbo, we had 4, and then it started to become weird with like O3, O3 Mini, O3 Mini High. But what's important to know, you have different companies, they have different models, and sometimes these models have the same name as the company, for instance, with a DeepSeek, but often they have a name itself, and then you have additional versions on top. Interestingly is that most of these models that we see, or these companies, were just founded in the past years. And as you know, it's like investments in the billions. For some industries, it's very easy to tell who is now the best in the market. I mean, NVIDIA outperforms any of its competitors in the moment. And often there's the question, yeah, which is now the best model, which is the best company? And it's very, very difficult to answer that in the field of large language model, because depending on like a certain time we are, maybe then ChatGPT is better than Anthropic, maybe a Google is better, but it changes like nearly every week or at least every month. What you can say is that typically the latest model that comes out are better than the previous one. However, the difference can be minor. But what is more important when you're using a large language model, rather than now which company or which model do you choose, is more about how it is distributed, because this impacts a lot how you can use the model. And one way of how these models are distributed is closed source. That's how probably most of the software was distributed in the past. This means you just have an endpoint to the model, can be with a web UI to ChatGPT or Google Gemini. And then you just make your prompt or you send your data and you get an answer back. What there is, the whole algorithms and the whole data is then running on a proprietary infrastructure. So you have no control over that. OpenAI is somewhere running all around the globe, some infrastructure, and there your data is processed. This has, of course, some benefits. You don't have to care about security. However, of course, it raises some questions because you then have your data on a third-party infrastructure. Typically, you have very limited options how you customize it. You may have some support, but depends also how much you use the service. You don't have to do any maintenance on it. If there's a new model, you can just switch it with a click, and you don't need any experience with it. However, as great as it sounds, often this closed source approach, the biggest limitation is the data, because you have data that is confidential and you cannot just run it somewhere in the world on some hardware. And that's when then open source model comes into topic. There are different models that are open source. And as of now, most LLM companies have some models open sourced. There are just a few, for instance, like OpenAI, who do not open source at all. What is typical that with some exceptions, it's not always the very latest model that is open source. However, as you've seen it with DeepSeek, there are also very state-of-the-art competitive models that are also open sourced. When talking about open source, I think it's very important to know that open source does not mean open source. there are different ways of what open source can mean. Normally, it means that you have the model that you can run, and you can just download it and use it however you want. But when we talk about fully open source, it would also mean that the data that the model was trained on, with which it was developed in the end, is open sourced, and the whole training pipeline. But typically, that's not the case. What the benefit of open source is, you can then run the model on any hardware you wish. You could go to a public cloud provider like Microsoft Azure or AWS, or run it also on your own hardware that you have inside your infrastructure. Of course, then you have the full control over the data, and confidentiality is then a less problem. But it comes also at a cost, because then you also have to manage the security. You typically have limited support when you use this distribution way. You have to do the maintenance yourself. You have to take care of the updates, and you also need experienced staff for that. Open source should also not always imply that it is free to use. There are different licenses out there, from you can do whatever you want and commercialize it, up to proprietary licenses, as we've seen it, for instance, with Meta's Llama model, where it is free to use until you have a certain a number of users, and then you have to pay a certain amount. And as previously said, most companies are somehow having these open source, like Meta, Mistral, DeepSeek, or also Alibaba. And some are completely closed, like we see with OpenAI, Anthropic, or DeepMind. What also is a question, not only which distribution you want to know, but also how you're going to actually use the model, how it is being used during the deployment. And probably the one that knows all and you use the first is the off-the-shelf. This means you just use the model like it is provided by the company, or you host it. For instance, this means if you just use ChatGPT over the browser, etc., you write a prompt to it, you get the answer, that's off the shelf. And that's great for very general use, some content generation. You do not need a lot of expertise. However, the limitation is there, that it is limited only to the data that it has seen during training, or maybe that it is now searching through the internet. When you now want to make like a connection to your company-specific or use case-specific data, you somehow need to give this data to the large language model itself as well. And this comes where retrieval augmented generation, or in short, RAG, comes within it. What you do there is you have documents, can be a few hundred, a few thousand, a few 10,000. You have a question that you want to be answered based on the information on these documents, and you give both the documents as well as your request to the model. It needs a little bit more of expertise and effort, because especially if you have a growing size of your database, in other words, your documents, you cannot give thousands of documents to the model itself, but you need to chunk it before, and you need to select only these parts of the documents which actually are needed to create your answer to the model itself. And this can be quite tricky sometimes. There's also this ominous prompt engineering, where you don't have to change the model at all, but you're not only asking it or instructing it, but you really give context to it. You say, for instance, let's say I'm a medical doctor, I'm a lawyer, etc. And this enables then that the model behaves in a certain way, and you have a quick domain adaptation. If this domain adaptation just with additional information for prompting is not enough, the last way that you have is then actually fine-tuning the model. Can be done with some closed source, but definitely with the open source model, where you can really extend the capability for this model to your needs. However, there you really have to know more about the whole data science and how you do the whole model training. Another big topic that came up in the last month is agentic AI. The big vision there is that you have an agent based on AI that has a certain autonomy, and you're not explaining every step that it should do. Rather, you give it a goal and it figures itself out what it has to do now. Often the idea is there that you have incorporated some decision making, it should plan for you. And the big dream is also that it improves over time itself. For instance, when you give feedback or it receives feedback from another source, and then it is possible to interact with other agents or other frameworks and really can execute tasks. However, reality of today looks like that there are some agents in some fields, for instance, like in software programming. However, with this general view of agentic AI, there are some limitations of today, since the memory is very limited of this model. They do typically not remember what you did a month or a year ago. They have no capabilities of self-learning. The reasoning, as you have seen it today, is not the kind of reasoning which we humans have. It's a more of like iterative prompting, and decision-making purely autonomously is also not yet at this stage. When we're talking about using an LLM really for a productional use case, we somehow need to have a performance measurement. And when we talk about performance, there are different metrics that are important. First one is accuracy. Means is actually the answer that we are coming back from the model, is it correct or is it not? But that's only one part of the whole performance estimation. Another big one is about, did it really solve the problem that I gave it to? Maybe the answer is perfectly correct, it's not wrong, but actually it does not help me with the task that I give it to it. More on the technical side, a lot is about efficiency, power consumption, how much compute do I need, which drives the cost a lot. And then on the usage, how safe is it for people to use, how fair for different people, and actually how robust is the whole answers that I get. As of today, there are many different benchmarking data sets existing. These can vary for different tasks. They can be of math exam, law exam, programming, etc., where it is tried to make it comparable, different models. However, it's not even there so easy, because firstly, maybe there's no benchmarking data set existing that actually is relevant for your use case. And just that it works for like one benchmarking data set, let's say in programming, does also not mean that it works then on your programming use case. And what is also really important to pay attention to, that sometimes these benchmarking data sets are not about what they sound like. Because, for instance, there's one benchmarking data set which is called human evaluation. And it is not what you think about. Human evaluation data set is purely just for programming exercises and has nothing to do with evaluating if the model is now like a human. So what are some limitations that we are still facing as of today? A very big topic is still the accuracy and hallucinations. Hallucinations mean that the model is simply not telling the truth, it just invents something. And latest studies show that depending on the model you take, you still have a hallucination rate between 30 and 50%. So nearly every third or even every second answer that you get from a model contains at least some information that is not correct. Moreover, these models, as we've seen it, what they do, they always predict what is the next word based on the word that they have seen before, but they don't have any like big intelligence behind it. So they do not understand the world as we as a human understand it. They just learned from the data that they got what the most probable word is that comes next. A super big topic also in research as well as in applying these models is with how can we detect when a model is no longer working? How can we make sure that we have this robustness? And if you have identified certain point of failures, it's often not that easy actually to correct it. Another point which I've not talked too far today, but is very important if you think about monetization, your solution is distillation. Distillation is the act where you're using a model, let's say ChatGPT, the latest model from OpenAI. And what you actually do, you send certain prompts and you collect the answers. And just with a few thousands of these prompts and answer pair, you actually can replicate to a certain extent the model of ChatGPT. So you don't spend billions of dollars in creating a new model. You just scrape data from existing models, and with this, you fine-tune your less performant model, and you like steal the intelligence or the capabilities for someone else's model. And I think that's also an important topic to address. So if you do your own model and you serve it to others, there's the risk that other can replicate it for just a fraction of the cost that you spend for your development. As previously mentioned, we have a constraint with the context length. We cannot give thousands of documents to the model itself. We have to reduce it. And also the memory is not unlimited. Depending on the model, costs are still quite high, especially if you scale it up. And of course, the topic with bias, fairness, security, and privacy still consists. Maybe that's you at the moment. At the very beginning, it looks sometimes very, very easy to just use a language model. And for very simple cases, maybe that works pretty fine. If you go in the nitty-gritty details, there are a lot of topics that you need to address. However, in the handout, there's also an extensive checklist appended that covers the most important topics that you need to think about when you actually want to have your solution in place, and also is a little bit of a navigation in the space. But to finish, I think it's important to not get overwhelmed by the whole topic, but to start exploring now. I think the most easiest is get one of these latest model hands-on, try stuff out in a safe way without exploiting data, etc. Just understand how actually these models can be used, where not, and to focus very much on the data and where you have the know-how in your data. Because keep in mind, if you can do something great with a model which is not connected to your own data, everyone else in the world can it as well. If you use it for brainstorming for a new business idea, etc., everyone in the world has it and has access to the same data, and probably hundreds of people are doing exactly the same as you do it. These models, they are generative AI. They are not creative AI. They are processing data, what they learned and what you give them. So they should also be used in a way that you connect your own data and the intelligence that you have with the data, and that you can leverage it with it. You have to be further really clear about what game are you playing. Are you just using an LLM to having your processes more efficient, meaning summarizing documents or writing emails more nicely, which do not really give you a competitive edge, however, they make you more efficient? Or are you really going more into using your data, maybe also in a sophisticated way with fine-tuning to have really better models that others don't have that could give you this competitive edge? And depending if you're more on, let's say, an easy to implement use case or not, it's also a complete different question about how much time and budget you need for implementing it. The whole space is moving so quickly. So you have to be aware that you need to continuously adapt to the newest model, to the newest interfaces that you get, but you have to start in the end somewhere. And I think what is also very crucial and what we see in our business often, that customers are struggling because they have no meaningful metrics implemented. Let's say you use a language model and you can reduce or you can make your processes more efficient with 10 or 20%. That's great. But actually, just being 10 or 20% more efficient does not directly bring you for your business a big benefit. With these 10 or 20%, you get more. If you just go drinking now coffee this time, you have the same output as before for the same time, but you have the additional costs of these LLMs. So you really need to think, what is actually what I get out of it? And if, for instance, here, if I have saved time, how can I then use it further? As of now, the two key messages for me are that you can use LLMs, especially if the output is verifiable. This means if you get an output of it and you can somehow a human checks it, or you have certain mechanism in place that verifies if it's now correct or not, that's great for an LLM. If you have an output that you cannot tell now, even with an automatic mechanism or a human, if it is correct or if it's not correct, then it becomes tricky. And I think you have to become clear, how can you, in your private or your personal life, leverage your skills and your competitiveness or your efficiency? Again, what game do you play? And I'm convinced that people who are using AI will beat people who are not using AI, but also people who are using AI together in a very clever way with specialists in that field will use people who are not, who are just using AI without deep experience. Where could it all go? Well, no one can tell where the future goes on, but very promising looks if we would have enhanced reasoning capabilities. As of now, these LLMs, they have some reasoning capabilities, but it's more like fake human reasoning. They do not understand the world as we see it now. Very promising at the moment looks like the combination of these foundation models, for instance, these LLMs together with robotics. Because at some point, you actually have downloaded the whole internet and learned the whole internet with these models. But to really understand how our world is working, we need to have embodied AI. We need to have robots with AI systems that go out, explore the world, and getting more and more real world data so that we can have more and more intelligent models. Of course, potential use cases could also be that in a few years, or maybe a few months even, we have personalized AI assistants that like know our whole private schedule as well as our professional ones, and who can help us a lot in our daily businesses. And what we did not talk about too much today, but also super interesting, is actually the word large language model is not that correct, because it's not only a language model, it's actually a communication model. And we see communications not only with words, but for instance, also in biology, for instance, with our DNA, which basically encapsulates information. And their possibilities are to leverage the capabilities of these models, not only with words, but information such as DNA in biology. And of course, somewhere, maybe also not, in the next years, we will see artificial general intelligence, like we have intelligence as a human. I now talked a lot, and if there are some questions, I'm happy to address them.
Thank you very much, Mario, for this super interesting deep dive into LLMs. You mentioned the hallucination rates, which are rather high. Like, it gives you again a little bit of a a reality check where we actually stand with the large language models. To the listeners, please feel free, if you have any question, to type them into the chat and we will pick them up. Maybe I can start with the first question. I mean, we see, you also said it, like the speed of development in this area is very remarkable. And as of now, some like LLMs have still some limitations. But if you think of, I mean, the optimal use, maybe some years ahead for organizations, especially if you couple up foundation models and robotics, like where do you see the optimal use in organizations?
I think it's always very difficult questions to address where the use is. However, what's an extremely simple, easy answer to give here is about do not think too much about what could be the future look like in 5 years, but more about how can you yourself and your organization be ready for these new models that we will see in the next years. And there the full focus is about data, where you have to ask yourself, which data do you have today? Which data could you collect digitally starting from now? And how you actually combine the data with the actual knowledge. Let's make an example more from an industrial solution, but I think it's quite easy to understand there. There are many companies who are producing high quality goods in Switzerland. And typically at the very end of the production, you have some people who are actually inspecting. In the very past, it was done purely with people looking at it with bare eye. And you had microscopes where you looked through, and at some point you had then the digital microscopes. And in this case, what is like lost value that you have in the data is when you're still doing this task, but you're not actually keeping your data. So you're not storing, in that case, your images that you have it. And the importance there is also not only like the raw information that you have, but to connect it with the feedback loop that the human gives. So in that case, you have an image and the person says it's okay, it's not okay, but you also need to store this information with it. So it's not only about storing the information, but also connecting it with the actual information, what's inside the data. And from time to time, we have like customers approaching us. They're very proud. They come at us and say, yeah, we now have 3 years collected terabytes of data that you can work with. It's amazing. And after some weeks, we actually figure out, yes, you collected the data, but what is actually missing is the whole information that is connected to this data. So in the end, you just filled your hard drives with something what's not usable at all. So it's all about where for my business is value in the data, how can I store the data, and how can I store the information that is tied to this data. So that in 2 or 3 or 5 years, when we have further, even more capable AI solutions, that you are ready, you can just pull it out your data and you can directly plug in, while the others are then starting to collect the data.
Thank you, Mario. So the importance of digitizing and collecting the right kind of data, I feel like is the new gold in that sense, and that companies can already start doing it as of now, if I understand correctly, to be prepared for whatever's coming.
Yes.
Yeah. I can see here that everything seems to be clear. So we do not have a question from the listeners. But maybe one other question from my end. We saw that the difference between the models, like the LLMs, you said that it's rather very limited. Like it can vary on a weekly or at least monthly basis. I mean, I guess you observe these developments yourself. So can you maybe say which models are like experiencing the quickest developments? Which ones are the best to use in that sense?
Of course, I would say from like my personal experience, there's nothing wrong with like using the latest model of OpenAI, of Anthropic, all the big players, Gemini, etc. You can also play a little bit around with them. If you're using Chinese models as proprietary, would be extra careful with the data, of course, also with the US models, but especially with the Chinese models. But what's also very important to understand is the quality that you get back from the model is not only depending on the actual model that you're using.
Mm-hmm.
Let's say you're using the latest model of OpenAI, which is 4.5. It does not mean that today the quality that you get back from 4.5 is the same as tomorrow.
Mm-hmm.
Because what happens is not that you just give an input and this goes directly to the model and then you get directly the output. There are many, many steps in between happening that these providers are doing to serve this model more efficiently. And this can heavily impact your user experience. For instance, what's happened in the past with OpenAI was that for being more efficient, it started heavily caching inputs. Caching inputs mean that it saves certain prompts that you give to the model, which are very frequent. And instead of really running the model, it just gives you back an answer that it saved previously for another user. In some occasions, this can be perfectly fine. If you ask the model what's the capital city of the USA, it will not change from today to tomorrow. However, then it's very difficult how do you know if this is now an answer that you can cache and not? And what happened in the past that you could get out answers from the model that did not were not really related to actually the question that you gave, for instance, or what you wanted to do. And then you told it, no, it's wrong, give me the right answer back. And then you got exactly the same answer back, etc. So it's not only that you have to focus on the model itself, but it can change nearly on a daily basis. But coming back to your questions, there's nothing wrong with starting with OpenAI, Anthropic, or who now also catched it up. They missed the game in the very early beginning, but they're now getting better and better, is Google with their Gemini.
Thank you so much, Mario. We have a question popping up in the Q&A section. I will read it quickly. Perhaps Mr. Russi could briefly explain once again the distinction between when one uses an AI model and when, due to his adaptations, he himself becomes the provider of an AI system. Is there a difference between the technical and legal perspective?
I think we are targeting two topics now. Talking about how you can use it, we're talking about you can just use it off the shelf, you can use it fine-tune with retrieval, augmented generation, or prompt engineering. In theory, you can use, or let's say in practice, you can use the closed source model for all of these, but very, very limited or not for the fine-tuned version. When you are using a proprietary model, meaning it runs not on your service, etc., you are way less accountable for it because you directly it's processed by not you, but the company, let's say, for instance, OpenAI. Once you, of course, distribute yourself a model, it becomes a lot more complex. We talked about the security, also the reliability, just from an infrastructure point of view. And legal-wise, I'm not a legal expert, but there, of course, it depends very a lot about to who do you serve it. Is it for internal use? Is it for external use? What's the use of it? So could it potentially harm users with output that it gets, which you have to carefully think about and address it.
Perfect. Thank you so much, Mario. We do not have any further question right now. I would like to take the opportunity to again thank you so much for joining us today and sharing these very valuable insights. Maybe a quick heads up for our next blockchain and innovation circle, where we will have the Dfinity Foundation joining us, and where we will talk about the internet, computer, and digital sovereignty in that sense. Your presentation, Mario, we will be able to share afterwards. Yeah, thank you very much again, and wishing you all a great day, and see you next time.